So 7-2, we're going to work on it for now, or 4-2, from now till the end of the week. So first we're going to start, these are the steps to follow for graphing rational functions. Remember a rational function was a function in the numerator and a function in the denominator. We are going to call this n of x. Actually, I'm going to write n of x.
Can you move it further down a little
Yeah,
bit?
sure. I always forget that you can't see everything I do. We have a function in the numerator and a function in the denominator. Why did I call it n and d? Numerator, denominator. Okay, so when I write n of x, I'm talking about the numerator. When I write d of x, I'm talking about the denominator. Okay, so the first thing you're going to do is you're going to simplify f. F is the whole function. Did we not just spend a couple of days doing that?
Yeah.
Yes. You're going to simplify f if possible. You must eliminate common factors. Okay? So how did we simplify f? What would we write there to remind us what to do? How'd you do that?
Isn't that factored?
So you factored
Reduce.
the numerator, and then you factored the denominator, and then reduced. Do you want common factors there? Okay. So, state the domain. You had to write the excluded values, that is the same as the domain, correct?
Yeah.
How did you find excluded values? Look at your worksheet if you need to look at your worksheet.
Like VA and HA? Or what? That's vertical.
Yeah, that's vertical and horizontal asymptotes.
It's x can equal 11.
You're getting closer. How do we find excluded values? What did we set equal to 0?
The factor. Once you factor, you set
What part of this?
the denominator.
The denominator. So you find zeros of d of x, factored d of x before you reduce, correct?
Correct.
So these notes are going to be like how you do it. Whatever you write on here is notes for you because these are the steps you're going to take. Okay? So now we're going to find x-intercepts. Now, we have found x-intercepts in every single equation we've ever done. And on an x-intercept, where a graph crosses the x-axis, what is the y every single time? 0. So every single time we set the function equal to 0, yes? Okay, so we're going to do that. We're going to have n of x over d of x equals 0. But if I'm to solve this, would I not multiply over by d of x? Yes? And 0 times d of x would be what? It'd be what? 0. So really what you have is n of x equals 0. You are setting the whole equation equal to 0, but when you multiply over by that denominator, the denominator is going to what? 0 out. Correct? So you really only need to set what to 0? No. Numerator. The numerator. N, remember, n of x is numerator function? Okay. and you find the zeros. And this is after you factor. Or do you want me, no. This is reduced. Reduced n of x equal to 0. This happens only after you what? Reduce. Domain is what? Before you reduce. Those are important. Domain is before you reduce. X-intercept is after you reduce. Okay? Then it says find the y-intercept. Well, how do you find what is the x value on a y-intercept, no matter the function? 0. So it says f of 0. So that means, what does it mean to do f of 0? Plug in what? Zeros. So plug in 0 for all x's and solve. Okay, so when I say all, that means in the numerator and in the denominator. This usually is easier with the original problem. You can put it in the factored reduced form if you want, but it's usually easier in the initial before you reduce. Okay? So now we need to find vertical asymptotes. We talked about vertical asymptotes yesterday, which is the h and the k, correct? But I showed you a little bit. Vertical asymptote, remember, is what it can never touch or cross, correct? Can't ever be. So a vertical asymptote comes from your domain portion of it, I guess I should say. How did we find the domain? Find the zeros of the factored d of x?
Yeah.
Well, here you're going to find the zeros of the reduced d of x. So this is after you reduce. The only thing that's before you reduce is what? Domain. Everything else is what? After. So this is reduced, and I have it right here. Do you see that? This should be a portion of your domain. If you reduced anything out, they won't be the same. But if you didn't reduce anything out, your domain and this will be the same. Like they'll be the same numbers. Okay, so horizontal asymptotes, we're comparing degrees. Okay, you compare degrees of n of x and d of x. I'm writing this over here for a reason because we're going to write the rules over here. Okay, so remember degree is the highest exponent, yes? Okay, usually, well, you use the original problem also. So if the degree of, so that's the statement for all three of these, okay? N of x is less than the degree of d of x, then y equals 0. Is the, what does HA stand for?
Horizontal
asymptote. Okay. If the degree of the numerator is equal to the degree of the denominator, the leading coefficient, oh wait,
What are you writing?
I'm abbreviating leading coefficient because I don't want to write that all out
Okay.
because that's a lot of words. And we'll go through all of these examples, okay? Then horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient of the denominator. If you need to write leading coefficient rather than LC, then write leading coefficient. I'll give you a second. Oh, it should probably be y equals, shouldn't it? Because it's an equation. Okay, ready for the next one?
Mm-hmm.
So we have less than, we have equal to, now we need to have what?
Greater
Greater
than.
than. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Now up here it says or slant. Didn't mention a slant, did I? Okay. So on this case, there's 1, 2, 3 rules. This is like 3A, but it goes with this. The degree, but if, we'll do this. If the degree of n of x,
By a degree.
if the, I forgot the degree of n of x is greater by 1, there is a slant. Asymptote found with long division. Okay. So after we do step 1 through 6, we would plot those on your graph. We will perform an interval analysis of all the intervals. Intervals are made by x-intercepts and vertical asymptotes of the reduced function. Because both x-intercepts and vertical asymptotes were of the reduced, correct? It reduced on both of those. Then you sketch the curve to complete the graph. Okay, so that's what we're going to do. You need to keep this handy so you remind yourself of all the steps you have to do. Those of you who are sloppy in your work, you might have some issues.
Yeah,
So let's do some examples. How's that sound?
not fun.
Not fun?
Yay.
Fun math.
It's going to be the most fun you've ever had.
Yeah.
Okay, so step one, write the problem on your paper, yeah?
No. Step one, not do it.
Logan, please stop.
It's messed with that.
Logan, please stop.
Oh,
Okay, so our first equation we're going to do is g of x equals 4x over x minus 3. I typically will do my work here and I will graph here. It just makes it, it's harder to do your work here and then graph underneath. It's easier to transfer it like this. Okay? So the first step says to do what?
simplify f as possible.
Okay, so simplify f as possible. This time it's g, not f, right? Okay, so can I factor the numerator?
No.
No. Can I factor the denominator?
No.
Nope. So is it simplified?
Yeah.
Yes. Okay, step one, check. Done. A lot of times you'll see me, even in my work, I'll just put simp, check. So I know I did it. Okay? Next, what am I supposed to do?
State the domain.
State the domain. So label everything you do. Okay? This is not multiple choice. I'm not expecting you don't have to do them in this order, but it helps to do it always in the same order. Okay? I will not assume that that's the domain unless you've told me it's the domain. Got it? Okay, how do I find the domain?
Zeros, factor d of x.
Okay, so find zeros are the factors of d of x. So you show me your work. X minus 3 equals 0. Yes? So what can't x equal? 3. So x cannot equal 3. X such that x cannot equal 3. Now you didn't need to show me adding 3 to both sides or anything like that. I just want to know where you got it. Does that make sense?
Yeah.
Okay. Everyone understand so far?
Yeah.
Next.
One x-intercept.
X-intercepts. So x int. Does that tell me what I'm doing? Okay. So how do I find my x-intercepts?
Plug in 0 for all the x's.
No.
That's what set it to 0.
Set what to 0? The numerator. So you have 4x equals 0. So what's x equal? What? 0. And an x-intercept is a point, yes? We plugged 0 in for y, and we got out what for the x? 0. So my x-intercept is 0, 0. If I can have a bunch of x-intercepts, but I can only have how many y-intercepts? 1. So if an x-intercept, if one of my x-intercepts is 0, 0, what better my y-intercept be? 0, 0 also, correct? So if I get 0, 0 for x and I don't for y, did something go wrong somewhere? Yeah, there's lots of checks in here. So the next thing is the what? The y-intercept. So y int. And just plug in zeros for x. That's what it says, right?
Yeah.
So you have, well, 4 times 0 would be 0 over 0 minus 3. So what do I get? 0. I just plugged it in. I didn't have to do the work. Does that make sense what I'm saying about showing work? Okay, so the point is what? 0, 0. Okay? Next thing? Vertical asymptotes. So VA. How do I get VA? Mm-hmm.
So I can put some concepts down already.
Oh, sure. Okay, how do I find VA?
Find zeros of reduced digits.
Okay, so zeros of the reduced denominator. So just x minus 3 equals 0 again is my work, right? So what's x equal? 3. So my vertical asymptote is x equals 3. It's an equation because vertical asymptotes are vertical lines and the equation is x equals, correct? There can be several vertical asymptotes, okay? But again, there's only one horizontal. Well, for most of them, only one horizontal. Next is the horizontal. Now, horizontal, we compared degrees, correct? So always write down the degree of the numerator. So what's the degree of the numerator? No, the degree. What's the degree right here? 1. What's the degree of the denominator? 1. So is the numerator less than, greater than, or equal to? Equal to. So that's my work. These are degrees right here, guys.
Oh, okay.
You got it now?
Like when it goes above the X?
Yeah, the degree. What's the degree? The degree of
So
the...
if it was like 2.
Yeah, it'd be 2. Okay, so now if it's equal, it says to do what?
If it's equal, d of x, the h of a, leading coefficient.
The leading coefficient of the numerator divided by the leading coefficient of the denominator. So y equals, what's the leading coefficient of the numerator? 4. What's the leading coefficient of the denominator? 1. So it is what? 4. So y equals 4 is my horizontal asymptote. Okay? So we've gotten through step 1 through 6, and it says plot step 1 through 6.
This is what we did finish. Try to make your tick marks reasonably spaced out the same. They don't have to be exact, but it does help to have them close. You can use tick marks unless you're skipping to like 30 and then just write 30. Does that make sense? Okay. So I'm going to put some colors on here. Domain, I don't plot the domain, do I? Nope. X-intercept, 0, 0. So you put a dot at 0, 0. Y-intercept, 0, 0. So the same dot, right? Vertical asymptote, 3. So you come to 3 and make a dotted line at 3. Okay, and then horizontal asymptote is at 4. So you go to 4 on the horizontal, right? Or it's going to be a horizontal line, right? So you go to y equals 4. And now you draw your thingy.
Not yet,
Why?
because you haven't
You have to perform
you have
analysis.
perform interval analysis and you don't know what that is yet. But before we start that, we're going to look at this. Remember, asymptotes are like magnets, so this graph has to go close to these asymptotes, yes? Yes?
Yeah.
Okay, so x and y axes, do you have to have a door to get through it?
Yeah.
Yes, hence the x and y intercept. Remember, if I happen to have a double, is the door open or closed?
Close.
Closed, so it's going to bounce, right? But do I have double on either one of these? Nope. So I'm going to have to go through this point, and I'm going to have to be near this and near this. So should this graph kind of look like this?
Yeah.
Should it? Yeah. Okay. Can it be up here?
No.
First of all, there's no y-intercept, is there? No. And if it was here and here, would that be a function?
No.
No. Okay. Can it be over here?
No.
Why?
Because it doesn't cross the Y.
No. The x? There's no door here, is there? Is there an x-intercept in here?
Okay, what is actually the door?
The x-intercept.
Okay.
Okay, is there an x-intercept?
No.
No. So could it be over here?
No.
No. Could it be up here?
No.
There's nothing up there.
No, we didn't look for anything up there. We only looked for x and y intercepts, didn't we? Didn't we? So could it be up here?
Yeah, but why couldn't it be here and here? Because then it wouldn't be a what? It wouldn't be a function. Okay? So interval analysis is going to tell us where we're going to graph this at. Okay? It's kind of our check. Remember when things are positive, they're above the x-axis. When they're negative, they're what? Below. So we think over here it should be positive, over here it should be negative, and it probably shouldn't be negative over here because there's no x-intercept, right? So it should be positive, and we'll put it up here. So we're going to check that out. Okay, so interval analysis, I just write int a for mine. So where do we get our numbers for the interval analysis?
Reduced function.
Where do I get them? It says it right underneath there. Perform an interval analysis for all intervals.
Of the reduced function. So you
Intervals
take the
are
reduced
made by
function.
x-intercepts. and
Thank you.
vertical asymptotes.
Intervals are made by x-intercepts and vertical asymptotes. What was the x-intercept? 0. What was the vertical asymptote?
3.
3. Okay, so there's where my breaks are going to be, 0 and 3. But on a graph, where do we always start? What's out here?
Infinite.
What kind? Negative infinity, right? So it's like we're a little person walking across the number line. We're just skipping away, whistling, having a good time, and we got some breaks. So we start at negative infinity. And what's my first issue?
0.
0. Is that on our list?
Yes.
Yes? So 0. So that's my first interval. I get around 0, and I keep walking. I would say that's like a pothole. Okay? Then what do I run into again?
A wall.
A wall
3.
or a fence at 3. I get over that fence, and then do I have anything in my way?
3 positive infinity.
3 positive infinity. Okay, so what we're doing is we're plugging in an x value and finding out if the y is positive or negative. I don't care what the y is, just if it's positive or negative. Got me? Okay, so I need a x value somewhere between negative infinity and 0.
1.
1?
20.
Well, 1 isn't between negative infinity and 0.
Negative 20.
Negative 1.
Negative 1.
Same difference.
I'd use negative 20, but...
What does matter?
Okay, I'm not doing the math, so it really doesn't matter.
Don't argue that.
So, write down what number you're picking. Okay, and we're going to plug it in the equation. If I plug negative 1 into the numerator, do I get a positive or negative number?
Probably negative.
Negative. So I write a negative. If I plug negative 1 into the denominator, do I get a positive or negative number?
Negative 1 is the denominator.
Negative. Because if I have negative and minus a number, it's going to be negative, yes? I don't care what the math is. Even though this math is pretty easy, I don't care. Got me? So if I have a negative divided by a negative, I have a what?
Positive.
Positive. So this interval in here is going to be positive. So between negative infinity and 0, it's going to be positive. So I put a plus up here. Just so I can keep track. Isn't that what we said should happen?
Yeah.
Okay. So now 0 to 3. Give me a number. 2. So I wrote down 2 so I can see it. If I plug 2 into the numerator, do I get a positive or negative? Positive. And this is usually easier in the original function, guys. Okay?
So what would the
And if I plug 2 into the denominator, do I get a positive or negative?
negative?
Negative. So I have a positive divided by a negative. I have a negative.
Yes.
Okay, so that's down here. Didn't we say it should go from here through that point and down? Okay, so now 3 to positive infinity. So 4 into the numerator, positive or negative? Okay, 4 into the denominator. So the whole thing is. So Can I be here positive?
No,
Why not?
because it doesn't have a point.
It doesn't have a point. Doesn't have a way to get to this other asymptote, does it? So it has to be where?
Okay.
Up there. So now you just sketch it. Nice, smooth curve
That was actually good.
going towards your asymptotes. And there you go. Now, the only time this would be wrong is if you went like this and down, like not smooth. Some people will go like this, and instead of going towards the asymptote, they like shoot up like that. Well, that would tell me there's a slant asymptote, and we don't have a slant asymptote. Asymptotes are magnets, right? Do you have to go towards them? Yes. Okay, on here, this is how I grade this graph. You have to have at least arrows on your positive X and Y axis. At least. You can have them on the negative if you want. I don't care. But you have to have them where? On the positives. I'll take off a half a point for each. Okay, so I have to see the asymptotes. Asymptotes are what kind of lines? Dotted. They cannot be solid. They're not real. I have to be able to tell where these things are going through. You can't just have it go through with no labels. Now, how do I know that's 3? Because there's what? 1, 2, 3. If it's not 3, if it's 6, you better tell me it's what? 6. You can just write 6. Or you could write a 2 here and then I could know it's 2, 4, 6. But you have to have some label if it's not just by ones. Got it? I'm not overly picky, but I have to be able to read it. The majority of your points don't come from your graph. Guess where they come from? The work. You get a point for the work and a point for getting everyone correct. But it doesn't actually take that long, especially when you're doing it yourself and you've done it. Okay? So let's do it again. I want to make sure, because that one was fairly easy. We didn't have to factor. We didn't have to do anything, did we? And the ones today are going to be basic ones. Okay, so I'm not going to jump to the hard ones yet. Okay, X. X squared plus, no, X plus 4. Sorry. X squared plus 4 over X plus 1. Is that right? Oh, I didn't say squared is on the bottom, not the top. X plus 4 over X squared plus 1. And what are we going to name it this time? F. How about H of X? Okay. So first step is to what? Simplify. Can the numerator factor? Nope.
Denominator can,
Only if the denominator, if it was x squared minus 1, it'd be x minus 1, x plus 1. But this one isn't minus, it is what? Plus.
Why does it matter?
Because if it was plus, it would have to have an imaginary. It'd be x squared plus 1 would be x plus I, and x minus I, which is imaginary, and we don't graph imaginary things. Okay? So, can I factor anything? Okay, so simplifying is done. What's next?
Domain.
Domain. How do I get the domain?
You can find zeros as factor denominator.
Okay, so I have x squared plus 1 equals 0. So that would be x squared equals negative 1, and I take the square root. Is that real? No. So you write Oh, wait. Okay, wait, you don't write none. Sorry. It's not real, though, right? So is there a limit on the denominator then?
Yeah.
Nope. So if there's no limit on the domain, I should have said domain, yeah. What is it?
Infinity.
What do we use? What do we say when it's everything? All real.
All real numbers.
So we just use that double backdoor.
I don't like that one.
Sorry. Okay, next.
You need to find your x-intercept.
Okay, so x-intercept. How do I find x-intercepts?
Plug in 0.
Nope. Nope.
What is?
Numerator equals 0.
Numerator equal to 0.
I just have to. I.
Okay, there's not very many of you guys participating, so if you don't know what you're doing, you better be writing more notes on that paper, right? Okay, so what is x equal?
-4.
So -4, so my x-intercept is -4 comma what?
0.
0. What's next?
Y.
Y. How do I get my y-intercept?
Same thing, just to the denominator.
No.
Plug in 0.
Plug in zeros in the original, right?
Oh.
So that would be 0 plus 4 over 0 plus 1, which would be 4. So my y-intercept is what?
0, 4.
0, 4. Next,
Vertical asymptote.
vertical asymptote.
Denominator equals 0.
Okay, vertical asymptote was denominator equal to 0. So we had x squared plus 1. So that was x squared equaled -1 square root. Is that real? So you just write none. You tell me there's none. You show me, you tell me. I'm going to know that the square root of -1 is imaginary. I better, right? Okay, next. Horizontal asymptote. Okay, how do I find that? Compare what two things? Degrees. What's the degree of the numerator? 1. What's the degree of the denominator? 2. So
1 is less than 2.
1 is less than 2. So what is the horizontal asymptote? Y equals 0.
Y equals 0.
Okay. Now what?
I want to get that.
What did you get? Because your first rule said, just you look at your rules. Your first rule says if the degree of the numerator is less than the degree of the denominator, the horizontal is y equals 0. Okay, so now I put all that on a graph. If you guys would like to work on plain paper, you can get the scratch paper. That's fine. I'm all good with that.
I used half a page, not a whole page, like I did the first one.
You usually can do 2 to 3 on. I usually do 2 on each side of the paper. Because if you squish up your work, you get lost in it, and it doesn't do you any good, so. Okay, we're here. X-intercept is at,
-4, 0.
so -4, 0. Y-intercept is at
0, 4.
0, 4. No vertical asymptote, right? Horizontal at
0.
0. Now, horizontal affects end behavior, just reminding you, okay? So, oh, my asymptote a different color. So this is where we do a slant line, right?
Why are you doing that?
The horizontal asymptote is 0.
Why
Okay.
did you do it on the last one?
Because they weren't on an axis. They were off. This one's on the this is on the x-axis, so you can't.
Okay, because you wrote it on that side.
Well, because it's y equals 0. That is the x-axis. Okay, so now I'm ready for interval analysis.
Oh.
Okay, so always start where?
The x-intercept and vertical s.
Okay, x-intercept was -4. And any vertical asymptote? Nope. So I'm going to negative infinity to what?
-4.
-4. -4 to...
Infinity.
Okay, so -6. I made the decision. Okay, if I put -6 in the numerator, positive or negative?
Negative.
Okay, -6 in the denominator.
No.
Positive, because you're squaring it, right?
Yeah.
So it's negative.
So it's negative.
Yes.
Okay, so it's down here. Okay, now we're going to go with 6. Numerator, negative or positive?
Positive.
Positive. Denominator.
Positive.
So the whole thing is
Positive.
positive, which I should have known because I have this here, right? Okay. So what is going to happen with this graph? It's really weird. This is an asymptote here, correct? So it's going to be close to it, and we're going to exaggerate. We're going to come down a little bit, go up, go through this asymptote, and then some point somewhere, we don't care where, it's going to come back down towards what asymptote? That horizontal asymptote. See that? You don't know how far it's going to go up. It could shoot clear up here and then come down. We don't know. That's for calculus to figure out. Okay? Does that make sense what I'm saying?
Yeah.
Because asymptotes are magnets, so it can go up, but then it has to eventually come where?
Down.
Back down. What are you doing on those 6 problems? Graphing. I don't care what else it says. If you get stuck, go to the next one and do everything you can do. If graphing trips you up, get all your other stuff. Got it? We're going to be doing this for the next 3 days, so we have to improve every day.